Okay, so now we're going to use basically the exact same kind of reasoning we use on the existentials right here. So existentials, after we did some examples, we kind of talked about the fact that for existential, double existentials, the order you did them in doesn't matter. It turns out for universal statements, the order that you put like the x and the y in here don't matter at all either. So what I mean by this is for all x and dx, for all y and dy, p of xy, that versus for all y and dy, and for all x and dx, p of xy. So what this is really saying is saying that for every x and dx, so pick an x and dx, any of them, and then pick out a y and dy, any of them, p of xy is going to be true. First you pick the x, then you pick the y, then p of xy is going to be true. Either way, though, because you're kind of looping over all of these, you're trying to check all of them, right? All this is saying is for every pair xy where x and dx and y and dy, p of xy is true. And this is the same thing right here. It's saying that first you pick a y, right, any y, and then pick any x and dx, then p of xy is going to be true. Once again, but since you're going overall, you're just picking an x and picking a y, right, you're going to check all possible combinations of x and y. This is saying for every xy pair where x and dx, that's not a D, it's only the first letter of my name, and y and dy, p of xy is true. By the way, I'm a boss of capital D's. The point is these two are the exact same things. So the order does not matter. Not matter for double existentials or universals, also existentials. Boom, done. I think that makes sense. Oops. Because we're saying it works for all possible combinations of them. But what does this imply? The way I wrote this is also equal to both of these.
The same is true of like existence statements, or?
Oh, you're totally right, right? Yeah, so if this is true, then there would exist an x and dx and y and dy such that p of xy. Yeah. Or the way you should write that is such that p of xy. Yeah, you're totally right, right? This is kind of like that quiz where you had the basketball player example, where it's like you said, for all basketball players are tall, that means there exists a basketball player that's tall, right? For all x and dx, and for all, if you know this is true, if it works for all of them, it's got to work for at least one of them, right? It won't go backwards. If it works for at least one of them, you don't know that it works for all of them. But what I'm getting at more is, can I write this? Can I write an equivalent statement without using two universals at all, without even using a multiple quantifier?
But yeah, you could use the cross of domains, right? And yeah, I think
Exactly.
Mm-hmm.
This is saying that for every pair xy where x and dx and y's and dy, we have p of xy is true. I only have one for every statement here, right? What this is saying is for all pairs x, y, in our set of ordered pairs dx cross dy, we get that p of xy is true. And by the way, this would be equivalent to saying for all yx and dy cross dx, p of xy is true. Doesn't matter. The point is that any of these pairs is going to work. So once again, just like existential statements, universal statements, double universal statements, you can write them as double multiple things, but it's really just kind of writing a single one again. We haven't really done anything quite new yet, except for using ordered pairs. Yeah, but we can think about it as double until it works. Yeah, and then real quick to add on to this, let's just do the negation. The negation of a double universal for all x and dx and for all y and dy, we get p of xy. Remember, it's just a universal statement where the predicate happens to be this weird universal statement itself. The predicate's just that. So this is equivalent to the negation of for all x and dx p squiggly of x, right? But we know how to negate a universal. That's nice and easy. This is just, right, the opposite of it happening for all x and dx is that there must exist an x and dx where it doesn't happen. That means there must exist an x and dx such that this p squiggly does not happen. I really regret using the squiggly now, but we've done it for 2 classes, we got to keep it. But then we know what p squiggly is. This is there exists an x and dx such that for all y and dy, p of xy is true. I'm sorry, the negation of this. Whoops. I raced too hard and broke everything. There we go. My camera killed me. Here lies Daniel Valvo. We mathed too hard. Anyway, so for all x and dx, you have the negation of for all y and dy, p of xy. And the negation of a universal, we know how to do. We just did it. There exists an x and dx such that there exists a y and dy such that p of xy. So that's the negation. Once again, real simple. The key is thinking of the second part here as a predicate itself, and then just follow.
Should it be the negation of p xy at the very end there?
Yes, yes, yes. Thank you, Alex. Because when you negate, because this is saying for all y and dy, p of xy is true. So the opposite of that is there exists a y and dy such that p of xy is not true. All right, not that p of xy is true. That wouldn't be the opposite of all. Perfect. Any questions on double universals? Good. Good.
One small thing is, right, like, so basically in summary is like, as long as the, like, either they're both for all or they're both there exists, you can combine them, right, as like the cross and a point.
Yep. If they're homogeneous, you can, they're really just making a statement about ordered pairs.
Okay, and then if they're heterogeneous, right, like where they're not the same.
Ooh, good question. Nice.
It wouldn't work, right?
Yeah. So